My name is Glaimi Hernandez, and this is my rant on Schrodinger's cat. Schrodinger's cat is a paradox created by physicist Erwin Schrodinger to illustrate quantum theory and the concept of superposition. In the paradox, we are often asked if the cat is alive or dead. To be more specific, a cat is placed into a box with a poison that has a 50% chance of killing it. Now, in answering the question, is the cat dead or alive, we are tempted to say one or the other, but in actuality, it is both. This is known as superposition. The principle of superposition states that in a given linear system, the net response at a given time is the sum of possible outcomes. Erwin Schrodinger used this paradox to explain that without observation of a physical system, you cannot say what something is doing, but rather it is doing everything it could be doing. The paradox was used as a reminder of the ridiculous ways particles behave at the micro level. More importantly, it led to the development of the wave function. The wave function is a description of particles' position at a certain time. In other words, it describes what a particle is doing and how it's behaving, and can predict things such as speed. The wave function squared describes the probability of finding a particle at a certain position at a certain time. The higher the amplitude, the more likely it is the particle will be found at that position. Schrodinger's equation works by adding the wave function within it. The equation plays the role of Newton's law in conservation of energy in classical mechanics. It predicts the future behavior of dynamic. It predicts analytically and precisely the probability of events or outcomes. The detailed outcome depends on chance, but given a large number of events, the Schrodinger equation will predict the distribution of results. However, you must remember that wave function is no ordinary number. It is a complex function that relies on imaginary numbers. Let's say, for example, there are two electrons with the same function, except one can be found here and the other one there. Once one electron is observed, the wave function collapses into a singular spot, giving the electron its position. The act of observation gave the electron its position. This relates back to Schrodinger's cat because the cat could not be defined until it was observed. The cat is both alive and dead. The electron is in two positions at once. When they are observed, however, the electron is found to be here, and the cat, sadly, is found dead. There may seem to be no real-world application to this, but in reality, the concept of superposition plays an important and useful role in quantum computing. Quantum computing strives to use the laws of quantum physics in order to find ways of encoding such as qubits.
Created using Powtoon.